In this segment, we're going to review and look at an overview of basic number systems. All of the number systems that we'll be reviewing today are referred to as positional number systems. In a positional number system, the location of the number is significant in terms of the value being represented. In the basic number systems that we're going to look at, the positional thought process is the same, so we will explore in this segment the base 2, base 8, and base 16 number systems, which are most common in digital design. Base 2 is many times referred to as binary, base 8 many times referred to as octal, and base 16 many times referred to as hexadecimal. To start this segment, we're going to review first a base 10 number, because that's something most of you are more familiar with in the base 2, base 8, or base 16 numbers. For example, we'll look at the number 653. 653 as a base 10 number is thought of in a positional form as 6 times 10 to the second power plus 5 times 10 to the first power plus 3 times 10 to the 0 power. And as we expand that and add it together, that gives us the actual result of the 653. Exactly the same thought process occurs with a base 8 number. If, for example, we take a base 8 number of 6507, base 8, and I'll use the small subscripted 8 to indicate this is a base 8 number, a positional notation would tell us that we're going to have 6 times some power of 8 plus 5 times some power of 8, again plus the 0 times an appropriate power of 8 plus 7 times a power of 8. If we look at this, we know that our least significant position in all of these numbers will correspond to the base to the 0 power. So it would be 7 times 8 to the 0, 0 times 8 to the first, 5 times 8 to the second, and 6 times 8 to the third power. And that would result in our positional representation of a base 8 number. And if in fact we go through and do those appropriate operations, we'll find the equivalent base 10 number to that base 8 number. As we move forward in this, we also will find that many times we'll be using base 16 numbers in digital design. Base 16, or hexadecimal, has a little bit of an additional complication in that in a positional notation we can only have one character for each one of the digits that we're working with. And in a base 16 number, we will have values represented in one place from 0 to 15. So as we increase from a value greater than 9, we'll begin using letters in those positions. A will be used to indicate 10, B will be used to indicate 11, C will be used to indicate 12, and so forth, with D, E, and F being used to represent 13, 14, and 15 respectively. As we go through and look at an example of a base 16 number, the number that I've chosen for this example is A72, base 16, and again the base is being shown by the subscripted 16. That would be representing A times 16 to a power plus 7 times 16 to a power plus 2 times 16 to a power. And again, the least significant place will be the 0 power. The next most significant digit will be to the first power. And finally, the third position in our example, the A, is going to be 16 squared. And if we go through, we can also think of the A as being 10 times the 16 squared. 7 would be just simply 7 times 16 squared, and 2 would be then 2 times 16 squared. And if we take the results of those calculations, we'll then have the equivalent base 10 number from this operation. By remembering in positional notation that each number is significant and its position is significant, we have a very easy way of going from any base number to a base 10 number, simply by taking the positions, adding the digits together. If we take, for example, yet another example with a base 8 number, we can take the number 7321 base 8, and if I asked you to convert that to a base 10 number, the process would simply be you rewriting the number as 7 times 8 to the third plus 3 times 8 squared plus 2 times 8 to the first plus 1 times 8 to the 0. If we go through and look at that, 8 to the 0 is going to be 1, 8 to the first power is going to be 8, 8 squared is going to be 64, and 8 cubed will be 256, so we then have 7 times 256 plus 3 times 64 plus 2 times 8 plus 1 times 1, giving us the result, or the equivalent base 10 number. Likewise, in a base 16 operation, if I give you the number A, E, 7, 2, base 16, to convert that to a base 10 number would simply be A times 16 cubed plus E times 16 squared plus 7 times 16 to the first plus 2 times 16 to the 0. Again, I would encourage you to go through, review your powers of 8, your powers of 16, and complete these examples to make sure that you understand the basic process of going from different bases to base 10 numbers. There will be an example quiz available for you to test your knowledge fully in this area, further in this area. Thank you very much, and good luck.